Anyways, TIC-80, it's a fantasy console. It's known because it's an open source version of the usual fantasy consoles. Pico 8 is more known. TIC-80 is an open source version-ish of Pico 8. There are some significant differences, but overall, the concept is that you have a limited set of pixels and a limited set of channels that you can use to produce sound out of it. And it's cool to make some retro aesthetic games. And the demo scene decided to hack the living crap out of it and make some demos and intros for it instead, which it was not planned for. Yeah, I'm going to show you a few things that you can do with a TIC-80. If you're a complete newbie to code, I will show you the basics of getting to grips with Lua in this case, and TIC-80. I'm going to explain you all the limitations that it has, the resources that you can check to see all the stuff, and hopefully on the last half hour I will show you how I would do a 512-byte intro for this platform in particular in time to submit to the compo, which you definitely should. It sounds daunting, but it really is not, trust me. So yeah, let's get right into it because we're already a little bit late. So yeah, TIC-80, you go to tic80.com, you have this thing here showing blah blah blah, what it is, fantasy console, you can see the sprite editor, you can see the map editor, which I never used in my life, only useful for games, I guess. Which I made 3 games on TIC-80, never used the map editor. You can create some samples, as you can see here, and then you can also go to the music editor and you can track the samples. So you have like a soundtrack that stays looping as background. The purpose that they had was to have like background for each different section of the game. So the structure is not like the normal tracker that you usually know. Anyways, click create, you go to the download section, you download the latest version that you have for Windows or Linux or macOS or Android or Raspberry Pi, according to your fancy. The Pro version has some extra features which we'll not really use, so it's fine. Also, if you compile the source from the GitHub repository, you have pretty much the Pro version. The Pro version is just if you want to support the developer. I think it costs like 20 euros or 40 euros, something like that. But yeah. So you download it. You can also, like, if you click here, you can use it on the browser directly, if it would load. But it's, okay, it's booting. It makes this bleep sound, and you have a menu here. Oh, I don't know what to do with the menu. You type help. Type would help. And help tells you the different stuff that it has. And if you do, for example, help spec, it will show you all the specifications. Like the display has this number of pixels, has this number of colors on the palette. You can put a gamepad on it. You can use your mouse or your keyboard. You can do some tiles if you want to do some sprite animations. You have the map thing that I never used in my life, as I mentioned. You have some sound limitations, and your code is supposed to fit on 64Ks of Lua. This is a lie. If you have the Pro version, you can have more banks and have more than 64K of code. But yeah, and it supports different sort of languages, which is also pretty cool. Like if you only are used to, I don't know, JavaScript because you do web stuff, you can use JavaScript and post some stuff for it. If you're used to coding for Roblox plugins or something like that, you use Lua, you're ready to rock. There's some esoteric platforms there as well, Skink, Fennel, Squirrel, all sorts of different things. WSML as well, you can see it here, and Python, if you like to be very careful with the tabs and spaces, you can also use Python, which is cool. The online version has some limitations, namely you can't save what you're doing, so I highly recommend that you download it. And after you download it, you have something called TIC-80, which I have, I think that's called? Yeah. Once it launches, it looks pretty much the same as before. And it saves the cards that you're doing in a particular folder, which is hidden somewhere. If you type folder, it will show it to you. is this folder. You can see here, very long path, somewhere in app data. I usually put my TIC-80 executable here, so everything is one place. You don't have to. You can have it in your downloads folder or whatever you want. But usually I put it here. When you save a new part, it will end up here. So I usually bookmark this folder and just have everything TIC-80 on this folder in particular, but you do whatever you want. So let's get started. As I said, you can use help to get the basic stuff. Online is slightly easier to read, but you have all the commands here. The point was to have everything inbuilt on the console, so you wouldn't have to go online. If you try help API, you can see, for example, all the functions that exist on the API of the TIC-80 that you can use. If you don't know what the hell an API is, it's called something application, something interface, or something like that. And what it is like a middle layer of coding between the programming language and whatever the hell you're doing. So it has extra functions that you can call to certain things on the environment that you're at. In this case, the TIC-80 sandbox that we're trying to use. So it has functions like there are higher case, these are the more important functions here. A BDR, which I think stands for border, but I don't really know. The boot function, which just runs one time once you boot the system. Menu, I don't know what the menu does. SCN is for the scan line to do things per scan line. We'll talk about it later. And then the tick, this is the main function that you actually need to know. This is your main loop. You're running anything graphical. I'll show you the code right here. So this is the main environment code. It's usually very hard to read beyond the line, so you can change between the big font and the small font. You click this little one here. I usually use the small font. If it's big projects, I use an external editor like Notepad++, something like that. That has Lua support, preferably, so you can see the stuff and autocomplete. Press F11. You go to full screen. Just mind-blowing, just like you're in the old times, like inside an old computer. So this is the main block of code that you have right here. This runs every single frame. So whatever you have inside here, this is your main loop. Every time it renders everything that is on the virtual bank, which is what's shown on the screen, and then it restarts this function from the beginning. It's always looping. You have 50 frames per second. I think it's 50 or 60, one of those. So it runs 50 times every single frame that you see on screen. You have some example code here. If you press a button, it goes to the left, or up in this case. If you press the other button, it goes down. Press the other button, goes to the side. So this is pretty much to control up and down. It's the arrow key. So if you run this, and to run you do Control R. You see this guy, this is the default screen. And if you use the arrow keys, you can see you can move the guy. Mind-blowing shit. Yeah. So let's go back to the code and see what's happening. So this is the basic of the stuff. You do an if function, you do call, check if it's true or false, and then you write something. If you don't know Lua, we have a perfect example here on how a basic if then else works. Well, there is no else here, but just type an else on it. CLS cleans your screen, which is good. Otherwise, it would end up a mess. I can show you the mess. I do as a minus. Lar. See, it didn't clean the screen. If I move, it leaves a trail because it's not wiping the screen. Every single frame. So the tick function cleans every single frame. So if you're not cleaning the screen, it will not be cleaned. But you can make some awesome glitch effects out of that. I'm all for it. But most people want to clean their screen. Then SPR stands for sprite. So you're drawing that particular sprite to a particular position. It has a lot of functions here, but it's really not that complicated. The first one is the ID of the sprite. If you go to the sprite sheet, sprite editor right here, you see F2, access it. This is the sprite sheet. This is where all your sprites, where you can draw them. Draw on top of them, whatever colors you want to use. You change the sprite. So what we're doing here is that every single position here on, I think it's 8 by 8. Yeah, 8 by 8 pixels has an ID. So this is sprite ID 0, this is sprite ID 1, this is sprite ID 2, this is sprite ID 3. You can increase the size, want to work. So this is still sprite ID 1, but it's just slightly wider and taller. So this is what they're printing pretty much here. They're saying, I'm going to start on the ID 1, and then for every 60 frames, and this function here in particular does the math floor. So it's iterating between 0 and 1, pretty much. If you have something rounded up by 60 and then math floor divided by 30, and then you multiply it by 2. So you go from 0 to 2, and if you add 1, you go from 1 to 3, which are the 2 positions that you have here on the sprites. Position 1 and position 3. So that's how you're blinking the eyes of the little guy when you run this. You see the eyes blinking? That's alternating between both. So since the main thing of using the sprite is the IDE and having this extra math to be able to do some small animations, but it's all based around time pretty much. So here they use T to count every single frame. You can see lower here they are adding +1 to T every single frame. You can also have a direct time count. If you do, for example, local, I'm going to call it Tim equals, where's the equal sign on this? Time. Why doesn't my equal work? That's not good. Is it in English or something? Yes. Okay. So if you have this, it will give you the time in milliseconds. I will print this so you can see after it runs the screen. I print the time and 0, 0 position and color 0. I run this, it will be on the top right, the time just adding up. So you don't have to stick to the frame rate count. You can also do directly the time count. If you want to do more accurate, I don't know, stuff with sinus and cosinus, you can use that. And talking about sinus and cosinus, I will explain you how to access the math function. So this has access to the basic Lua stuff. There is a math library, so you can call math.sine and the function. And you will see this will iterate between -1 and 1, which is very, very fast, so you can barely read it. Let's make it a little bit slow, like divide by 2000. So you can see it rising up to 1, then going back down, all the way to 0, and then going -1. It's the basic sinus function. So it's the mother of all animation functions that you can use. You can also do some advanced trickery to interpolate between values. I leave that as an exercise for looking up on the web how to use those functions. There are some of them already available for JavaScript, like those websites where you have the list of all the different interpolation functions that you have available. Easing functions, I think it's called. Let's try to Google it up real quick. Easing functions. Oh, there are some. Yeah, cheat sheet that's okay-ish. And some of these, if you click, you have like the code of it. This one is for, okay, you have the math function right here. So you have to port this into Lua, for example, and you have an ease in function for this, and you have like a whole option of different ways to do a transition from one point to the other. This is called an ease function. Don't know what it is. Welcome to How to Animate Stuff 101. Which is different ways from going from 0 to 1 that you can use some simple math functions to do those tricks, so you don't have to bang your head against the wall to try to figure out the best way to do some smooth transitions between things. So yeah, easings.net apparently is the way to go. What else can I tell you about this? Sprites, where they talk how to define the ID. The other functions that you have is the place on X that you want to place. So the horizontal position of the pixel, you know that you have 240 pixels wide, so you define on the X which one you are doing. You can see here that it starts at 96, which is somehow in the middle. If I would have like a 0 here or a 6, it would start closer to the left side of the screen. So you see the the sprite starts there. So you can define in what position of the screen you want, and then you can, using the time functions, the some animated functions, you can make it move in some different ways. I can, for example, add here the sinus function, so you see it wobbling a little bit. I can even multiply it by, I don't know, 10, so it gives a little bit significant wobble. And, oh, no, I don't want to do it on the ID, I want to do it on the X position. Okay, so this will change the X position a little bit. So you can start to do some basic animations out of this. And now what you want to do after this, you want to complicate things. And for that, you usually need loops. So I will teach you how to do a basic for loop in Lua. And I hope I get it right, because I always fuck it up. For I equals 0 to, I don't know, 10. Do something. You can also do like steps. If you do an extra comma here, like 2, it will do 2 steps at a time instead of doing 1 by 1. It will do whatever value you define here. And then you have to remember to close the loop to an end. And then whatever you want to do, you can do it inside here. Let's try, for example, drawing a circle, because they're easy. So circle takes X position, Y position, the radius, and the color. So only 4 characters. So let's use, I don't know, 20 plus the time. So it changes a little bit. Multiply it by 10. Y position is going to be fixed. I don't know, 30. Radius can be whatever we want. I think the minimum is actually 0, and it just gives you a dot. And if you have a 1, it gives you like a small cross. So you can do some interesting effects with that as well. And then the color, to pick a color, you can go to the sprite editor. And you see the palette right here, or the palette of all the 16 colors that exist. So 0 is black, 1 is purple, 2 red, etc, etc, etc. For advanced users, you can click the advanced mode and select the color, click this little edit palette icon, and you can actually change the colors. Because we said it's 16 colors, we didn't say that it was fixed. It comes by default, TIC-80 comes with the Sweetie 16 palette, which are these 16 colors that you have, but you can define whatever colors you want. You can even change them inside the code. While you're running, you can change completely all of these colors or just a few of them. You just need to know the right place of memory where you poke the information to change the color. You can even do it per line, so you can have multiple colors going at the same time. For now, let's just, I just wanted to show you that you have this feature and talk a little bit about the colors. But you have a little color select here. Let's go, for example, with blue. So you can see here on the top, it says color 10. So let's try to use that one. Color 10. So this will show you a single circle moving, because I didn't differentiate itself. It's behind the sprite, so I'll get the sprite out of the way, put it back where it was at 96. You can see the little blue there. Blue is a bad color. Let's try something that stands out a bit more. Let's go with 0 because it's black. Okay, so now you can see the circle here. Now let's try to differentiate it with the eye that we already have here. And I go for example on the Y position. I have the eye, and I'm going to multiply it. Instead of being 1 by 1 position, I'm going to skip a few steps so we see the whole of the circle. So multiply it by, I don't know, 4 should be enough. So we are able to see it. See the different circles here. We have 6 of them because we go from 0 to 10 in steps of 2. If I take the 2 away, you have the whole 10 of them. Amazing, mind-blowing. And if you add that I variable to the X, you can also affect some stuff there as well. Mind-blowing. You can even multiply it with time, so it's affected by time. Ah, incredible. So yeah, these are the basic things to do a basic loop. Of course, these are basic things. You have to try to simplify it a little bit. A little bit of math goes a very long way. A lot of math goes astronomically better. So the better you are at math, the easier it is to figure these things out. Pen and paper is pretty good, but you have a very good debugger, which is the visual output that you're being shown right here. So try to make an effect out of that. These are a few things. You can do some stuff like putting pixels on screen. You can do all the entire pixels. Let's do a quick, instead of cleaning the background, let's do a quick plasma effect, for example. Which is 4 for every single, I can't use X, but I do XX from 0 to 240. Do 0 to, I think it's 196, I think. 136. And now here, for every single pixel that is that you're iterating through, you can do a pix, and you type the X, the Y, and the color that you want to give it. And we're going to give it something random related to time, so everything is slightly different. So if you do like just X plus Y, for example, if it's bigger than 16, it rounds up back to 0. So yeah, you can see this, like it's just random stripes, which is X plus Z. If you multiply it by a math of some sort, or you can even XOR it, do some fancy stuff. Where the hell is my XOR function? I can't find it here on this keyboard. I think this works, I hope. Not really. Or? Okay, this is a bit better. So I'm XORing the values of X and Y, which for people who have some informatics engineering background, this says a lot. For those who don't, it says nothing at all. You're basically masking one value with the other, and doing like, if one is positive and the other one is positive, then you have a 0 value, and you're adding all those values up. So it's called a XOR. So what else can we do? We can multiply by time. If we add math.sine, and inside the sinus function we include the X position or the Y position, it will change some stuff. You want to include the time as well itself. So let's have time divided by 1,000, something like that. This will only change one value, slightly up and down. If it works, it has no integer representation. Because I'm XORing here, I guess. Yeah. It's slightly moving each color. Probably will see it better or notice it better if I do this. Okay, a bit better. So we have something on screen. Something is better than nothing, right? So you can do 512 bytes now, because you have something going on the screen. You can change some values, do some stuff. If you know some proper programming, you can try to do some initialization of buffers and stuff like that. Maybe go crazy and do a particle system. So all of these things fit into very small-sized things, and I will teach you how to optimize for that as well. Let's quickly go over the graphics and music things that are inside the TIC-80 by default, and then I will tell you how to use those, but in a different way for size optimized stuff. So right now, if you go to the sound effects editor, by default, the TIC-80 comes with a single sound effects, which is sound effect 0. And it's mapped to wave number 0. You have a total of 16 waves that you can define on the whole TIC-80, well, per bank. But on the default TIC-80, you only have one bank, so 16. But you can do multiple sound effects with all these different waves. Usually these waves are something like, the basic square wave, saw wave, double saw wave, if you're crazy, which is this one pretty much. Triangle-shaped wave. You can even do your custom design, like if you're feeling creative. It all pretty much sounds like a bleep. It's just chiptune music. This is the part where if Genio would be there, we would maybe have some music. But he's not there, so we'll have to wait until he's back. But yeah, it does a beep. You can preview it here. Higher, lower. You can see the name of the note here on the top editor, so you can remember. And then by code, you can call that, like whenever you hit, for example, a button. Whenever you're hitting this button, you can call that specific sound effect. So if I go down, I'll do sound effect 1. Note, which is usually you can type C4. You can also put a number in it. And I think you have to say the length or something like that. I think just this works. Let's see. Yeah, it works. It works forever because I didn't define the ending time, how long it takes. So probably like 2 will be a short beep. Yep. And if you want to know what functions, what inputs each function has, again, you can do help, API, SFX, or help SFX probably directly. If I could type. Come on. Okay, very long piece of text, but summary is here. Write the ID of the node, write what node it is, -1 is to shut it down, and then you have 0, 1, 2, 3, starting from the C1, I think, all the way up through all the scales, all the 8 octaves. So the first 8 are the first octave, the next 8 until 16 are the second octave, so on and so forth. If you know anything about music, you probably know what a note is and what an octave is, so I'm not going to explain that. Duration is how long it will play for. The channel that we will be played on, because we have 4 channels available, luxury. The volume, how high it is, and by default, these are on channel 0, total volume and speed, whatever speed it's supposed to be playing on. So yeah, this is the bottom line, and any other effect that you don't know exactly, you can type help and the command of that, and it will give you the stuff. Like, for example, help triangle. I don't know how to draw a triangle. How the hell do I do a triangle? It's right here. First 2 vertices, the second 2 vertices, the third part of vertices, and then define the color. So you can do this for whatever function that exists within here, which is listed on help API. So these are all the functions that exist. Trigger buttons, draw circle, clipping is for doing, you want to draw some stuff, but only on certain parts of the screen. You can define the clip area to be just, this rectangle here. So even if you draw a huge circle, you will only show part of the circle. So it's useful if you want to do half shapes of with the native functions for drawing shapes that it has. CLS clears the screen. LE draws an ellipse, an ellipsoid. The B version at the end means it's only drawing the border of it, so not fill, only does the border line. So you can do some neat tricks with that as well, like draw the filled side and then draw the border with a different color, stuff like that. Exit kills the screen. fget, I don't remember what it does. The font, you can define the font through here. Amazing, the stuff we learned. Keys, to hold down the keys to know what key you're touching. You can draw a line as well, define the starting position, the end position. You can do some cool stuff with that. The map, I have no clue what it is. You can copy memories from one place to another. Only useful if you know the memory map of TIC-80, which is not that hard to do. If you go to the TIC-80 website, you have the map. Where's the RAM? RAM. Left. RAM. Oh, it's right here. Click on the RAM. You have here the memory map of where everything is stored. The idea is that it's emulating like the old computers used to be, where everything is in memory. Like a computer without memory doesn't do anything. So the code as a piece of memory, what is being drawn to the screen as a piece of memory that is being drawn every single frame. where your mouse inputs are, where your keyboards is, where your sound waves are. All of that stuff as a memory position. So you can see here all the list, and you can peek and poke to these positions to know what value is there and change what value is there directly. And do some funny glitches to the stuff, or update data in runtime without having to use the editor, the sprite editor or the wave editor. You can do it by code. You can change the values in there. It's particularly cool to do with colors, so you can change the colors in real time. But there are other uses for doing some other things. It shows you also the color for what's being shown on screen. The palette is defined. All the information, the different segments of the memory are described on this thing here. So if you want to pick and poke directly, you can go for this. For novices, it's not very useful, but for people who know what a memory is, what a byte is, you can do some cool stuff with this. Going back to the TIC-80. So I showed you how to do a sound effect, how to play a sound effect. Next we have music. So we go to the music editor, and you have a pattern editor. There are some things on sound effects that I didn't mention. So when you defined a new sound effect, you click here the little icon. I'm changing sound effect number 1, and I can define here what is the default waveform that it uses. But you can actually go here to the waveform editor, and you can actually, it has what's called waveform mapping. It's not the proper name for it, but you can change the waveform as the sound effects plays. You can change the waveform, so you can use different ones from the 16. You can go to different ones and back. If you click here, you will reset, which is a common mistake that it does. Like right now, if I play a sample, you can see it going up and down and changing the sample that it's being used on the select wave. It also takes more CPU to do all these changes, but if you click like on this one, it will reset the sample completely, because it assumes that you want this sound effect just using this sample. So that's a common mistake, which I had to learn the hard way. The editor is a bit quirky in that, but after you know this thing, it's pretty easy to be aware of. You can change the volume of the sound effect, so it starts quieter and then ramps up, for example. Which you don't hear anything because we don't have it on the loudspeakers, but trust me, it does that. You can affect arpeggios, you can affect pitch changes, so you can do some basic effects here to make the sound effect unique and customize it for some stuff. Not very useful for size optimized things, but it's useful if you want to make a proper soundtrack for a proper demo in the long run. If you're a musician, you want to do your own instruments out of these sound effects and then track them in the music editor. So yeah, music editor. So there's a music editor embedded into the TIC-80. It plays these 16 frames by order. There are multiple tracks, as you can see here. You can switch them. The idea was that for each phase of the game, you will be playing a certain track in a loop mode. So you would always play these sequences of music, and you would, when you transition to another section, you would play another track. For demo scene purposes, 16 frames is a bit too short. Sometimes you can do demos short enough that only use 16 frames. Most of the times you have to know by code what frame you are playing, and by the time that it ends playing all the frames from that track, you have to start playing on another one. So it's hacky, but it's manageable. So how the hell do you track for these things? You have 4 channels, as I already mentioned previously. You have a piano roll thing here, which you can just click and it notes the things. Then you can scroll down to all 64 rows of that frame that it has. So you can do some things here. And when you play, mind-blowing shit. It plays these 3 different ones. You also have some effects that you can do. I particularly like the arpeggio, the play chord one, because it does automatic chords for you. You can just come here and play 3-7, and it does an arpeggiated thing, which sounds a lot like cooler, like you actually know music theory, despite you not knowing. At least I didn't know it. I know some of it. I know enough that you need 3 notes to a chord, but then there are chords that you need more notes, and then it's complicated like hell, and there's this way and there's that way, and you know. Right here you just put 2 numbers and it sounds okay, and you can get away with that. You also have another view to make these things. There are a few other effects, which I guess I should talk before going to that view. If you want to jump to another frame before reaching the whole 64 rows, you can use this to trigger that. There's a slide to note, so you can do some legato. There's a fine pitch way to change the pitch, vibrato, the sound, do some delays. So a few little touches, which if you're familiar with the tracker format, these are common, and you can do some interesting stuff. So this is the piano mode, where you see the piano here and you just hit the note that you want. And there's the tracker mode, which is supposed to be like the usual trackers used to do. You have all the 4 channels here. You can select what pattern each channel will play. You can select what frame you are currently changing. And if you want to copy paste some stuff from this pattern to do a new pattern, is a headache because I didn't really think that through. But it is doable. You have to Alt-All, I think, or Control-All, Control-Copy, create a new frame, and then Control-V. And it sort of works. But if you want to do this for the whole 4 channels, it becomes a little bit annoying. So that's one of the main strifes that people have with this tracker in particular. Anyways, if you're used to old trackers, it's very easy to use. Just define what patterns you want. You can define different ones. It reuses the same ones for every single channel. You can find the tempo, the speed, blah, 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 the rows. It's like a traditional tracker in that sense. Okay, so this is the traditional way they want you to make music on the TIC-80. You go to the music editor, you track your music here, you make a loop that works, then on your game, on this phase, you play this thing as in loop mode. And to do that, you just write, there's an easy way to do that. Instead of writing SFX, you write, I think it's music, and then the number of track that you're on, the number of pattern that you're on, then some few things if you want loop mode, if you don't want loop mode. And this plays the music. You have to do some checks if the music is already playing or not. In this case, I triggered it to a button, so it will only start playing once when I hit the button, so it's fine. But if you're having that bug, you know, it's up, I think. Yeah, it's playing, mind-blowing. So yeah, so these are the basic things that they want you to do for the TIC-80. So, what does the demo scene do with TIC-80? We try to break the living crap out of that. There are a few things that you want to know for that. First, you want to know how the file is done, like the card itself. Gassman did a nice tool for that you can reorder the chunks of data. So take, for example, sprites from one card and music from the other card, put everything on the same card together, stuff like that. You can do scripts to interrupt that, which is really cool when you're doing a mega demo where everybody did a different part in different places. You want a tool to put everything together. For small projects, you don't really need it, but it's really useful for slightly bigger projects. You have like the whole file description here of the different chunks of the card data here that you can use to do some different stuff. And if you have troubles using it, just ping Gassman and he will explain a little bit better to you how it works. Then we try to do some size coding stuff for it, and the TIC-80, you can optimize TIC-80 to some degree. Like, you know, this takes 670 characters, you can see it here on the bottom. And if I do some stuff like, you know, I'm gonna remove the metadata here, and I don't need to have, you know, Lua auto detects that it's a new thing. Actually, 0x will screw up because 0x is the hexadecimal short key. So this one will actually not work, but if I do a space, it will. And I can try to narrow down the space to something that fits, you know, 512 bytes or 256 bytes. Demoscene people thought that this was a bit annoying to do. We still do it for 64 bytes and 128 bytes. There are some tricks for this, but for higher, still tiny size coding, but slightly higher categories, like 256 bytes, 512 bytes. Some people coded some tools that will actually strip all the extra information from the cart and only leave the code, so you have smaller size code. And I will explain this a little bit better. So right now, if you save this, and to save, you type save, test. Now, it's saved on test. Oh no, where is my test? I go to folder, and it shows up. The test is here, and you can see the file size is 2K. How the hell is it 2K? It says that it was 400 bytes. So your whole cart size is actually 1.5K in size, because it has all the extra data, not just the code. It also has the music, it has the sound effects, it has the pixel data, which if you're just coding a single effect without using the graphics data or the music data, you don't really need. So some people coded some tools that just cut that part out and use the compressor, because by default you can use Zopli compressor on the cards. And so yeah, there were some tools for that. Backtick is one of them, was one of the first ones that were created. Then we have also TIC tool made by Exoticorn, which took it to the next level. Also has some heat maps where you can see where it's compressing better or worse. So if you change the order of some variables or some variable names, you can see the difference in compression. And then there was this Finnish guy called Pestis, which thought, that's a lot of work. I don't want to compress everything by hand. This is it's supposed to be my Finnish accent, but it sounds more Russian. I don't know why. So I'm going to do this tool that just takes everything and going to do some simulated annealing things and just iterate like hell, do all possible combinations and put some key marks on how to change the code. And so you can use it changes operators automatically for you, so you don't have to do all that. It reorders operations, try and maintain. It allows you to do some conversions of variables. It tries different variable names. It does all those fancy code golfing tricks that you had to think of. Does it automatically for you. So everybody went, Pestis, you're the man. That's really cool. And now everybody uses Paketic to compress their stuff. There's some additional tricks to this. You can see, like, for example, you can switch the orders of the different elements. So if you have a variable saying A hello or B world, if the B is before the A, it might compress better because reasons that only the compressor knows. So he tests both and see which ones does better and then uses that one. Same way for rearranging loops. You have loop inside another loop. It might work better if it's the other way around, because you might be reusing a variable somewhere and it might compress better that way. So he has a few things that you can use. I barely use any of these special things. I just tell it to iterate like hell, and it usually takes away, 20 bytes or 30 bytes from the original size code that I had. So yeah, there are a few different tricks like that. Long documentation, you can check it out, but this is the boilerplate. Is you code an effect, you don't rely on the sound, or if you do sound, you only use the basic sound effect that comes by default. You use the default palette, so you don't have to waste any bytes drawing a palette. You don't use any sprites, so you draw everything. And then you use Paketic to compress it down to usable sizes. And usually when you do a basic effect with Paketic, you get around 128 bytes, 256 bytes. So you still have quite a little bit of space to do sound. There are a few different ways to do sound on TIC-80 for size coding stuff, not the ones that I explained before. The one that is mostly used for 512 bytes is Crackle Tracker, made by Pestis again, because he didn't want to code music by hand, so he made a whole tracker for it. That's the Finnish mentality of doing things. Which I highly appreciate, because I used a lot this, and I never bothered doing music by hand much. Well, I did some glitchy stuff. I should probably talk about the other ones before I get into Crackle Tracker. We're gonna download Crackle Tracker, and I'm gonna explain how it works, so you can use Crackle Tracker, because it's a lot better than the other alternatives. But I'm gonna summarily explain the other alternatives. I still have 30 minutes, so it should be fine. So yeah, if you go to the size coding wiki, there's a section dedicated to the TIC-80, and there's this part somewhere here which explains a few tricks on how you can optimize some stuff, blah, blah, blah. Where's the sound? The sound, the sound, the sound, the sound. Make some noise. Here we go. Make some noise. So you can, how does the sound on TIC-80 work? So you have this, I think it's called a sound register, where you are generating your sound wave and then you are sending it to the sound buffer that fills this register. So you can either, every single frame, either you can update that buffer with information and that gets played to the channel. And if you don't know what the hell you're doing, it makes some weird glitches, sounds, or maybe assign a sound, which might work. I have used it for some productions. You can write some frequencies as well. You can see here a basic way to do that. It wastes a little bit of bytes because you have to do some extra pokes on stuff. So these are mostly for, we call them bit banging. So we're sending bits to the buffer and hoping for the best, hoping that something works well. Needs to be bigger. Control plus. Where's my control? There we go. So yeah, this kind of works. If you know some sound coding, it works even better because you can code your own small synths. Although for 512 bytes, you're very limited on what you can do in terms of sound for coding your own synth. So what people usually do, either they do this and throw some random bytes at the buffer, and you hear some and hope for the best, that it matches the visual somehow. The other trick is to call the SFX function that we already talked about previously. So this SFX, where is it? Where is it? Where is it? Did I delete it? I guess I deleted it. I can write it again. So this SFX, you have one SFX by default, right? And you can say you will use the 0 by default, and you can say what note it is. So if you increase the note every single frame or every n frames, you will hear a scale. If you apply some math functions to it, you can do some changes in the scale, and then you have 4 channels to play with. So technically, theoretically, you can do some different sort of magic with that. It's a relatively simple function, so it doesn't take that much space. And I use it for quite a few things. It's usable. It sounds a lot better than glitching the buffer. It sounds more melodic, even if you do it properly, which is kind of good. Some people say that that's that's the actual definition of music. But yeah, I would use Crashcourse Tracker, and let me show you Crashcourse Tracker. Do I have it downloaded yet? I don't think I do. Crashcourse Tracker is a bit of a hack. You download this cart to the place where the TIC-80 is, which should be here. Thank goodness I saved it. Okay, saved. Now I will, there's a command on TIC-80 to check whatever it is on your computer. It's called surf. You're surfing the console, I guess. It also has a very cool feature, like if you want to check other stuff that other people have made, it has a direct connection to TIC80.com, so it shows all the productions that everyone uploaded to the platform. So if you go through here, I'll show it real quick before I go to the other one. You can go through, I think it's in play. And it even has a demoscene section and a live coding section where all the jam stuff where people have done on those jam sessions of 1 hour. They saved them, they uploaded them here, so you have a few of them available here. So for example, the Duck Jam is not per se a jam session, it's a mix of them, but whatever. Anyways, Hype Train, let's check this one. Yes. It's doing this, as you can see. It's changing the colors a little bit. It has a floor simulator. It's simulating a cart of some sort. Let's take a look at the source code. And you can see all the source code here for all the different things. So you can learn a lot by just surfing the different things that people did, seeing how they did those things and reapplying them and trying an effect of your own. You can see that this effect is not that big. It's only 1K and a half. drawing a few rectangles for the different parts of the thing. It even has like an Ashi logo here that's being drawn on it. So yeah, a few circles. And I'm looking for where they're changing the colors. I'm not seeing. It's probably the it's here, the scanline function now. So I didn't talk about scanline. I guess I can talk about it briefly. So on traditional consoles, you would have a memory for what's on the screen, and I guess F11, so it's bigger. The other F11. It would draw everything that's happening. It will draw the entire buffer. And I think it was Amiga that had the scanline concept for the first time. By the time that it ended the first line, it will call a function, or in old console was an interrupt, where you could do a piece of code before drawing the next line. So we had a little bit of time there. And you could do some changes. So they try to incorporate something like that, and in TIC-80 you can abuse it to do some effects. The main ones that we do is usually change the colors. So for example, the background is entirely just one color blue, and they do the aliasing of the sky by doing different pokes on the color blue depending on which line it's listed. So you can do some interesting effects like that to change the color. You can also change the color of the borders as well, which I'm a very big fan of, but usually waste a lot of bytes for size coding doing that. So yeah, there's a small trickery like that. Let's take a look at the code, and that's exactly what he's doing here. For every line on the scan line, you see the L here signifies the line from the top to bottom, 136 of them. It calculates what he wants to poke, and he goes for color 20. Well, it's not 21. It's adding 21 because it's in groups of 3. It's color 7. My math is not correct. It's changing color 7, and it's changing both the red material on it. It's changing the green, and it's changing the blue. Green and the blue, because you have 3 channels per palette, RGB. So yeah. Changing them dynamically, and he uses these functions to calculate that dithering that you saw. So if I only have L here, you will probably see totally blue screen, I believe. Oh, it's affecting the train itself. So the dithering on the sky is made by code. The dithering on the train was the one that was using the scanline trickery. I'm gonna play it back as it was before, so you see the difference. So you see here, the degradé is on the brown. That's what he's changing on that scanline function. And you can use it for different colors as well. So yeah. If you do pokes like this, it compresses very well because it reuses the same stuff. So that's some small tricks that you can do for size coding stuff. So yeah, let's go back to our thing. We were looking for Crackle Tracker. So Crackle Tracker is the de facto thing that you can use to make music for 512 bytes intros. And if I could find it, I could even open it. So it looks like this, pretty damn horrible. These are the 3 instruments that you have. He calls them instruments, but I think he actually means channels, because it's the only 4 channels that you have on TIC-80. You can define the waveforms that you have. It only has 3 waveforms possible. 0, I think it's sine. Then it probably has a noise, square wave, and a triangle wave. If you reuse the same, it's cheaper to compress, but then you don't have as much variation. You can define, for these 4 instruments that it has, you can define what waveform it will use, what octave it will play on, which we want to start, I don't know, 4. The semitone that it does for more advanced stuff. The duration, also advanced stuff. The filling is definitely advanced stuff, but I will explain it later on. If it's muted, if it's not muted, which is only useful for debugging, if you want to only hear to this one. And the slide, which sometimes crashes the exporter, so I don't recommend you trying it, and I never really quite understood how it works, because whenever I tried using it, it would crash something. So yeah, I would suggest you ignore the slide. You can define how many patterns you have playing. and the order in which they are played. So I will show you a little example. So 4 orders, 4 patterns. Here I will use instrument 0, and I will tell it to play pattern. It's already playing pattern 0 by default, or they're all playing pattern 0 by default. If I play now, it crashes, which is really cool. Attempt to divide by 0, that's great. Probably because I didn't add anything. Oh, I have no clue why it crashed. So you can see it's a very stable program. It's ready for deployment. Let's try putting something here. Might help. Please play. Oh god. Also try importing something that already has some code. It used to work. It used to work. Let's try a new one. Shall we try a new one? Does this play? That's better. Just do a new one. Do a new one and you're ready to go. Yeah, I think because internally it has to create the tracker data inside some other place. So yeah, you need to click new one. Okay, good. So yeah, you already saw some action there. So what it did, it defined that on the first, for the first instrument, it will play pattern 0. And then for instrument on the ID 1, it will play, for example, pattern 1, which I can put doing different things. These patterns pretty much just say the octave that it's playing, the octave range. So for example, if I do 1, 2, 3, 4, 5, 6, 7, 8, it will increase the pattern. So let's try that here and see what this does. And now it would be really cool if Genio was here and turned on the sound, so you guys could hear better. So you get the overall idea. You find this instrument, you find that instrument, and whatever patterns. You can reuse the same patterns. Like on the 2 different instruments, it uses the same patterns, which compresses better. And one of both of them are rising. I can play each one with different waveforms. For example, this one uses this waveform, and the other one the other one. Mute this one. Okay, I don't hear anything with this. Okay. Boop. Okay, nice. That's a lot better. So the first, and then by the time, so back on the order, it will repeat the same order a certain number of times, which is the pattern repeats. So on the order, you're defining the order of what it will play, and here you are saying that it will play pattern 0 8 times. And after that, you will move on to the second one. This is to try to make very short things. Genio, the sound from here is not playing to the audience, I think. If you can fix that, would be nice. So the idea is that you do very short things, so you don't abuse this order all of this way down, or you don't use all the patterns. You only do like 2 or 4 of them, and you have just a little bit of variation on the fact that you want to do, and you have a very basic music that just goes through an array of notes, maybe trying to fill up something like this. Two, and I'll put, I don't know, bass drum or something. Okay, we're starting to have something, and we still only have an order. It just repeats 8 times the same thing. can tell it to only repeat 4 times and then skip to something else. And there's this particular thing which is called a fill. So what the fill will do is that instead of doing all of the 8 orders, it will only do the filled ones and then do something else instead, going to the next order of the pattern. So for example, instrument 1, if I put the fill here of 4, it will do 4 using pattern 1, and then it will go to pattern 2, pattern 3, pattern 4. So let's try that. 1. It already changed. Only has 4? Should be 8. Or I didn't count. 2, 3, 4. And now it changes? Yes. Okay. So you get the idea. The pattern repeats the number of times that the pattern will loop, and the fill is when it goes to the next one. So you can do some trickery of having some special patterns on the next to the original pattern. It will, on the first 4 times that it loops, it will do this sound, and then on the other 4 times, still on the same order without using more orders, it will do something that sounds different just on that instrument. So you can do a lot with just 1, 2 orders, which is what you want to do to make sure that you have the space smaller as possible. We're going to have only 1 order. That's enough for what we want to test out. I think I put a 1 here. That's it. Song duration is only 17 seconds. We can live with that. And now how the hell do we export it? We can save, click here. It gives you a print on the trace, which is very nasty. You have to copy paste all of this. All the way, you have to use the mouse wheel to scroll all the thing, and you copy paste this into a file. And if you want to reload Crackle Tracker and a different song, you will have to load this. If you keep using Crackle Tracker for just this one song, you're fine. You save, and when you reload Crackle Tracker, it will show you the same song. But if you want to use multiple ones, by the hacky system that the tracker is built, you need to save this aside and then load this before you load the rest of Crackle Tracker. So yeah, just wanted to show that real quick. But this is not how you export. When you export, you have to click the export button here. And it will give you this other text, which you also have to copy paste using the mouse wheel to go all the way up. I screwed up, so I'm going to do it the other way around. And now Control C, I think. Okay. So now we can go to a brand new code. I'm gonna actually save it on Notepad++. Make sure I don't lose it. Control V. Not that Control V, the other Control V. Okay. I don't see anything, I bet. Okay. So yeah, this is what was exported from Crackle Tracker. This is all the data that it has, and this is the loop where it plays the sound. For every single channel that you have, if you're only using 2 channels, you can do like this instead of 3. It will calculate the position of the order list, which are only using position 1, but you can use this variable to change scenes in your thing. It's going to repeat the same order position 8 times, as we already knew. It calculates the envelope. For example, it defines the waveforms that we are using. In this case, we are only using 2 instruments. If you had more, it will list them here. It calculates the note that's going to be played. You can record this value as well per channel, so you can have it externally from this loop available as well. It calculates the envelopes. Actually, it stores the envelopes at the bottom part of the D array for optimization rules. Like you have these 4 values here that are not being used for anything. He will store the envelopes there dynamically. So outside of the main for loop, you will be able to access the envelopes of that stuff and do some synchronization things with that. And you can do some similar things for the note. I usually do like m equals an array of something initialized with just 0, 0, 0. I'll close it. Yeah. Remove the 9. And then to save the notes, after it calculates it, which is here, I do like M position K equals the note. So I also have the note that is being played right now because since my pattern is going from 1, 2, 3, 4, 5, 6, 7, 8, I will have a note difference, and I can use that to synchronize some stuff as well. You can try a simple effect using that as well. And then outside of this for loop, you can even do, like, if you can do your code, your visual code inside this for loop, so much the better. You can use the n variable directly. Otherwise, if you need, go per pixel or something like that, you can call d something to synchronize that stuff. So it's a bit more advanced, but I'm just showing you how the code works for the player. It does all of this, and then it calls the sfx function, because it's basically just using a single sound effect, saying what channel it uses, and octave and envelope drop that it uses. Yeah, it runs. There's a bit of a hack here to just run until it ends the song and then it exits. This compresses well, so this is usually what is being done. If you don't want your application to end right at the end, you have to change this a little bit, but this compresses really well. So let's try to put this on our Lua screen. I need a new Lua banana. Okay, I have a banana card created, I think, or okay, now I definitely have a banana card created. It starts with the default, which we don't need for anything. I'm gonna delete this. I'm gonna copy paste the code that we had from the Crackle tracker, and hopefully it will play correctly. Mind blowing. So we have sound playing. Now we just need some visuals. First of all, I want to clear my screen because I'm one of those crazy people that do that. I clear the screen. Plays music with a blank screen. Amazing. Mind-blowing. And now for each of the channels, we can visualize what the hell that it's playing. For example, I can do some circles. For every, I don't know, 30 plus, it's k is the variable within this loop. I multiply it by, I don't know, 20, something like that. So the x position will change, the y position will be the same, which will be 20, I guess, should be fine. The radius, we can also change it. We can use the note for that, for example. Let's go crazy, use the note on that. And then the color. We can also change the color of that. So let's see how this works. Huh? Okay, works, ship it. So if you want to do any more advanced visuals, you have here a boilerplate code. So, just starting points, try to make the music on Crackle Tracker. Try to put some graphics underneath it, either within the for loop, so you can reuse that for loop that is going per channel. Or you can create some additional stuff before or after that for loop. Let's see how much this compresses. Right now you see that's 1K. Oh my God, we are beyond the limit. There's no way we will ever be able to do 512 bytes out of this. But luckily we have Paketic, which I hope I have Python here. I remember I tried to install it. It should be here. Did I download Paketic? Of course not. That would be too easy. Let's download Paketic first. Paketic releases. Where's the download button? Paketic. TIC-80. Perfect. Here, export, extract. Why the hell does Windows 11 has these weird menus instead of just having the 7-zip unzip? I think it's extract all. Goes to Paketic. Bam. Now we have Paketic installed. Amazing. So to use Paketic, you need to read the documentation, which is very annoying. But I think it boils down to calling Python Paketic or -m Paketic, the name of the card, and then the output. I think that's it. If If it doesn't, we'll look it up. So we are in Paketic. We open a CMD. We hope that we have Python installed. Otherwise, I have to install Python. Great, perfect. How the hell do you exit thing? Yes, okay. So Python, I think it's -m paketic .py maybe, or maybe not py. I don't have it here. Is it in the distributions, in the paketic folder? Paketic/my. Maybe this just works. Let's try test this. // I called it banana. .tick. And then I want to put it on banana. Where's the slash? Banana packed. I think it outputs Lua or tick. I think it works for tick as well now. See if this works. Blah, 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 blah. And now no module find. Maybe I need to do pip install or something like that. Where are the documentation? Pip install paketic, but I already. Let's try to pip install paketic anyways. Maybe the gods will be kind to us and it will just work. Pip install paketic. For those who don't know what pip is, it's like the manager for different repositories of Python. So it automatically installs you locally the library that you're trying to use. Can't find main in paketic. What about if I put the -m here? Does this work? Why don't I have Zoplif? Why don't I have Zoplif? So it was working okay. It's just it doesn't have Zoplif. Maybe it needs dependency or something. Yeah, should just be Python -m paketic. I think it's missing the because I install it manually without doing pip install. Maybe it's installed somewhere else, but it sees the local directory, but the local directory doesn't have the dependencies that it does. How the hell do you install the dependencies on a pip packet? Is it? I don't know. I don't know what it is. I'm going to delete the local directory or remove it to something else. I think when you do pip paketic, it automatically installs on your computer. I don't know where, but if you called Python -m paketic, it will get it from there. I think so. I hope so. And here would be just .type banana. And oh my god. But it is finding paketic. It's just not finding Zoplif. DLL download failed. Importing zip protocol. Maybe I need to pip install Zoplift? Zopfli? Any Python expert in the building? Otherwise, it will be left as an exercise to the reader to get this working. It works. I used it at home. It works on my computer. We're out of time anyways, so 5:30. I wanted to show this working, but yeah, it packs down about more than half. I want to say 3/4, a little bit like that. So it goes down from 1K that you see on the TIC-80 here. This goes to about probably 400K. So you still 400 bytes. So you still have some room left to optimize some stuff and add some more stuff. So yeah, I'm gonna wrap things up. Are there any specific questions that anyone has about stuff that I just said? There were some more tools that I could also show you to make demos instead of intros, but I think it's more interesting to try focusing on intro. It's more achievable within a day. So yeah, anyone has any questions that I can answer? Yes. No, F11 or coded on the notepad. Most people that don't like the restrictions on the font size, you code it on notepad and then copy paste. You can also trigger, if you use the pro version of TIC-80, you can have an auto reload, like loading from an external source, which is handy. You can just hit save and it automatically shows up on the card, which is nice. Okay, if no one has anything else, we're going to wrap things up because we're already running a bit late and we have to prepare for the next seminar. I'll be around if you have any specific questions. If anybody can figure out the Python issue on their local machine, please look it up. It's probably documented somewhere on Paketic. I just don't have that to figure out right now. But yeah, thank you everybody for listening. Hope you found it useful and I hope you try to make something for the compos that we have tomorrow. So yeah, thank you everybody.